Okay, for this part, we're going to talk about the one rule with numeric data. So what I've done is I've opened up the weather data, and except for the nominal data set, I'm using the numeric data set that comes bundled with Wicca. And right now, if you just look at what we see here in the preprocessed screen, it looks the same for Outlook. Outlook is still a nominal feature. However, if we click on temperature, we see that, oh, this is actually numbers, so it's telling us the statistical stuff that we know how to deal with now. And then likewise, if we look at humidity, it's numeric data. If we look at windy, that is still a categorical feature. So it's nominal as well. So we have four features, two nominal, two numeric in this data set. If we now want to run the classifier, so if we do the same thing we did before, I need to change it from 0R to 1R. And so if I select that, and if I run it, if I just click start, then remember that we have to scroll up to see what's going on, to see the interesting stuff. And so what we get is the same rule as before. It's based on Outlook. So we could say, well, there's no difference. There's not anything we can do about it. But we actually do have some control. If I click in the classifier text box up there, then I get a dialog that pops up. And I see that that parameter 6 is something about the minimum bucket size. And I don't use the word bucket much, but a bucket is a synonym for a bin, and we'll take a look at that in a second. What I'm going to do is I'm going to make it smaller. I'm going to change it from 6 to 2. And then I'm going to rerun. I'm going to start. And so one nice thing about Wicca, you can see it knows both of the times that I've classified. So I can see the history of things I've done. I can mess around with different approaches, and then I can compare them and pick the best one. This is where data mining can be as much of an art as it is a science. You can change parameters, you can pick different algorithms, and you can compare them all. And we have all the output from everything to do that. So let's find out if we did better or worse. Let's scroll back up and let's see what we have now. And so what we see, now we actually have a different rule, and it did better. It goes to 11. It did one better. And so what we have is 11 out of the 14 instances are correct. So somehow when we changed the bins or the buckets from 6 to 2, we ended up doing better. If we want to understand why that made a difference, then what we need to do is we actually need to look at the data again. So let me go back to pre-process. Let me clear the screen here. Let me edit so that we can see the data. And what I want to focus on is the temperature data. So I'm going to click on it so that we can sort it. And so what we see that we end up having is that for the temperature data, this is numeric, it's not nominal. Okay, so that's great. We knew that. What we want to do if we want to use the one rule with this data, what we have to do is we have to convert this to a nominal feature. And the way we do that is by binning. We say that, okay, I want to pick some bins. I want to pick a range of temperatures, and I want to call that a nominal value. So it could be that we want to split the temperatures up roughly into thirds. And so we would want to have something like cold, cool, and hot, or cold, mild, and hot, whatever the divisions we had before. And so we could be arbitrary about that. And if we do that, then we do the same thing we did before. We come up with the rule that goes with the majority. So we would have a rule like if temperature is less than, what value does it have to be less than? It's not 70 necessarily, and it's not 69, but what we would do is we would actually split the difference. We would say if it's less than 69.5, so we put something in the midpoint, then play is yes. That's how we would come up with this rule. So that's how we convert numeric data to nominal data. It's always going to be by a binning procedure. And so that was what our parameter was. If we don't want to use the word bins, then what we would say is in this case that we have 3 buckets. That this is a bucket, and then likewise we have another bucket here and another bucket here. So if we can reduce the bucket size, if we can say that, oh, well, it'll be okay to have a minimum of 2 instances per bucket, then we can actually end up doing better because we can have more and more rules. So what we do is we get a bucket or a bin we can think of as a category. And so if we make the bin smaller, we can have more categories. We get one rule per category. The more categories we have, then the more accurate our rules can be. So more categories come about from smaller bins or buckets. And what that means is more accuracy. So that's why as we decrease the bucket size, we found out that the temperature rule won out over the outlook rule. So the best we can do with this is if we decrease the bins down to 1. So in that case, we can have a rule for every value of the temperature. And so in that limit, if you want to think of it that way, we can have a rule for almost every instance. We might be able to get 100% accuracy. So let's do that. Let's change the minimum bucket size to 1, and then let's reclassify everything. So start, we get a third instance of us doing that down here, and oh, well, we're not 100%. We got 13 out of 14 right. It's also worth pointing out that we do get the rules here. So why didn't we get 100% accuracy? So if we go back one more time, look at the data set, sort the temperature, we see, oh, there's one little gotcha here, and that's where we have two instances that have the same temperature value, but then they have different results for play. So there's no way to be 100% accurate. If we split just on temperature, which the one rule wants to do in this case, we're not always going to be right. But this illustrates how the bin size affects things. It determines the number of categories that we convert a numeric feature into a nominal feature with.